Next we have Dr. Shashibhushana, DGM, Environment and CSR, Bharat Electronics Limited. So he'll be showing us the efforts at Bharat Electronics, their treated water use case. Interestingly, they get tertiary treated water from the municipality, and they also provide treated water for lake rejuvenation, etc. So he has seen both sides. So I request him to take over. Thank you, sir.
Very good afternoon. Am I audible? Yes. I'm Shashibhushana, working as a Deputy General Manager, taking care of the environment and the CSR in the Bharat Electronics Limited. So I'm here to give the presentation. On one side, just how industry what we perceive about the water and how we handle the water, because it is one of the critical resource. Unlike material, manpower, water is also one of the essential resource for us. How as an organization we are taking care of the water, and sometimes always the aim for any organization is to go water neutral, positive to the highest level to give back to the society. In this is the context. In this we are going to make presentation. So this is about the overall water balance, and every organization will have a roadmap. The roadmap for being the water neutral and to water positive. So in this context, we started working from the 2000 itself, how to become a water neutral and water positive. So in the 2000 itself, when BWSSB, they have constructed a tertiary treatment plant in Yelahanka. So BL has become the partner with them, and dedicated line of 8 km was laid from Yelahanka to BEL just for using it for the horticulture application. Though we have got a 2 MLD treatment plant in our organization, so our water requirement is very high. So we did not want to use the groundwater at that time itself for the horticulture application. So non-potable application, we wanted to use the tertiary treated water. That is the reason from the 2000 onwards, initially it was 19 rupees per kiloliter. So we are purchasing and we are using it for the horticulture application. So in addition to, because our horticulture requirement is around 365 million liter. So per day we need around 2 million liters of the horticulture water, because our factory is spread across 685 acres of land we have. Since we are in the electronic manufacturing company, either we cover with the lawn or we cover with the concrete. This is the concept. Since entire 685 cannot be covered with the concrete, everywhere we are covering with the greeneries. So we have got around 3 lakhs of different species of trees, and we have got around 3 lakh square meter of the lawn. That is how we are maintaining, and we require water especially for the maintenance of the garden. See, though we are an electronic industry, our water consumption, we are not that water guzzler as compared to the either textile or textile or paper. So within that context, so since we are stationed in the Bengaluru, we started operating on the risk management approach. Water could be a risk in any of the day. So based on that, we started taking the tertiary treated water from Yelahanka. So then what we did is in 2003, so we constructed a very big rainwater harvesting pond. It is having 10 acres of land we have spared for the collection of the rainwater harvesting from our entire campus area. So then onwards, we started from 10 onwards, we started using the rooftop rainwater harvesting. So what we did is we directly connected the rooftop of the many of the production facility and connected for the RO itself, because TDS of the rain is around 60 plus or minus 10-20 it will be there. So that water is the better output. The first output of the RO will have the 100 TDS, whereas the rainwater will be in the range of 60. We started using directly into the production of the RO. So then we started constructing the local recharging pit and rainwater harvesting sump, and later on we realized that, so with that we have to go beyond our factory for the become the water positive. So that is the reason we have rejuvenated one Dodubamsandra lake, which is nearer to the our factory premises. These are the roadmap we have started. Now after 2021 onwards, within Bengaluru, BG complex, our area and nearby area also we have rejuvenated. Now we have gone in for the forest region, Malay Mahadeshwara Hill. So what we have done, that also we will just show it to you for the information. So this is how we treat the water. See, our approach is first conservation of the water through efficient use of water in all our industrial processes. Next one is the rooftop harvesting, then recharging the groundwater table, then reuse of the tertiary treated water. This is our broader approach in which we are handling the water. So first conservation of the water. Just few example I will give you. So though there are different processes are there, different applications are there, what is just applicable to the BAF forum, that's what I have just truncated my overall sustainability presentation and given here. First one is some of the process we automate it, so that the required water only will be used. So then for the electroplating, we use the treated water. What we do is generally we go with the TDS mapping. What is the TDS of the fresh water, TDS of the recycled water, and there will be a first rinse, there will be a second rinse. Accordingly, we will go with the supply of the water. If the initial rinsing purpose, then we are using the high TDS water of our own plant. Then where the TDS we require less than 5 ohms, so there we are going for the RO water. Like that we are segregating the different levels of water and we are using, and again it is a demand based supply in order to conserve the water. And next one is what we did is groundwater drawing. Groundwater drawing also we did automation of the system based on the yield of the bore well. We set a level sensor controllers for the sump, and that is linked to the demand based pumping system, and we allow it for the repercussion rate of the each borewell was studied, and accordingly we set the timer. We allow it for pumping 1 hour, 2 hours, and then we allow it for the borewell to get refilled for the repercussion. So that is how automation of the borewell also we did it. Then level controller for water, because entire our sumps are spread across 600 acres of land. Sometime it will be just overflowing from the borewell. If the laborers are switch on and leave it, it will be overflowing from the sump. Next day only we will come to know. So in order to avoid that, level control systems and automation of the borewell we have incorporated. And so in our canteen around 12 to 13,000 members take a food every day. So efficient dishwashing system also we used with the swill water and air agitation in order to effectively use the water. That is also been implemented in the dishwashing facilities and all. So this is some of the example. What we do is, first one is the cooling system. Wherever the coolers are there, that requires lot of water, and evaporation is around subjected to the cooling capacity and all. Some places it is around 4,000 liters of water will go for the drift and evaporation losses. So then the next system was came was the Celdac media, which is some media which is holding the water, and thereby we were doing the cooling. Now latest technology is going for the air cooled system, water to air cooled system. So totally there is a elimination of the wastage of water in the form of the evaporation and other things. So that itself is saving around 1000 meter cube of water per annum. So next one is, as I told, smart groundwater system. This was very much appreciated in the CAI forum, how totally every system was interlinked and efficiently we are drawing the groundwater from the borewell. So next one is, as I told, the rooftop harvesting. Rooftop harvesting was created around 500 to 600 meter cube of the rainwater. Directly we are using, we are taking it from the roof and we are using it for the RO purpose and our further application. Then the recharging of the groundwater. Our first scheme is directly collect from the roof. If not, next local recharging pit spread across the factory. Local recharging pit we did it. So overflow from that local recharging pit we have diverted for we have created a 170 million liter water holding capacity tank in 10 acres. There it is being recharged for the application. So it is having the potential to recharge around 234 million liters per annum. such a big rainwater harvesting facility we have created. So these are some of the photographs. First one is how the rooftop harvesting directly we have planned. Next one is the local recharging pit. From that it goes for our recharging pond. So some places we are collecting the roof water and directly we are giving it for the our apartment reuse purpose. Because see, all our buildings has to comply for the Gruha green rating assessment, green rating for inhabitant assessment. All our building has to comply with that. You shall have the low embodied energy material. So then you shall have the dual plumbing system, energy efficiency, solar integrated lighting connection system. All those things will be there. These are all part of that. So then we also collect in our rainwater harvesting tanks are also there. It is collecting 5 million liters of water. The Bengaluru rain is such that previously we used to get around 100 incidents of rain. So it is so that 1 or 2 days it will happen, then there will be a gap of another 4 or 5 days, then again rain used to come. So we used to collect in a 5 million liter holding tank and we pump it back for our industrial applications. So this is how we use. We use our we generate around 2 million liters of our water and we also take 1 million liter. We were taking from BWSSB 1 million liter of the treated water at a cost of 19 rupees. Now we were paying 25 rupees. 25,000 rupees per day is our BWSSB treated water cost from Yelahanka to our place. Whereas we are paying 90 rupees per 1000 liters because ours is an industrial tariff. Tariff is very high. 19 rupees is for the treated water. So this is these are our treatment plant. We have got industrial effluent treatment plant. It is very specifically for treating the heavy metals. Then we have also got the sewage treatment plant for the whatever the human waste is being generated in the factory to handle that. And these are totally separate. Industrial effluent treatments are separate and domestic wastewater treatment is separate because industrial water goes back for the same plating and other application. Domestic water is used for the horticulture application. So with that we were able to reach up to the water positive level. Then what we did is we have gone beyond our boundary. So this is one of the lake is there, Bomsandra Lake. Bomsandra Lake is around 125 acre is the land spread. In that water, this was not getting water. It was dry for a quite long time. So then 2017 onwards we started with the government and Friends of Lake and other groups started. So we have to do the rejuvenation of the lake. So then one place was identified within the lake and which is available, which is of about 1.2 acre land was available. In that lake itself we have constructed one sewage treatment plant which is having 10 million liter handling capacity. It is a SBR based technology. So the operability of the SBR technology is such that 1 million liter also we can operate 10 million liter also. So that facility was created and now lake is totally rejuvenated. Model is developed in such a way that 2 million liters of the treated water will be taken for our BL horticulture application. We are not taking the tertiary treated water from Yelahanka. Remaining 8 million liter is only for the rejuvenation of the lake. So it was planned in such a way that the lake evaporation and transpiration losses is accounted from 4 MLD to 6 MLD. Another 2 MLD excess water is available for the other use. What was planned is it was taken for the above upstream also we have got 2 lakes. So treated water will be pumped for the above 2 lakes, Narsipura Lake and Tindlu Lake is there, then Bomsandra Lake is there. From Bomsandra to it goes to the Hebbard. This was the overall concept. It was developed. So in the previous government it was taken under the Brand Bengaluru development scheme. They wanted to do that. Now because of so many geopolitical reasons, so the another 2 lakes revival has not happened. Now it is collecting only the rainwater from the rainwater and it is now the water level is going down. So around 3 lakhs population is benefited, which is 750 million liter water body has been created as of now. Now one more touching point what is happening is now many lakes are going dry. There are so many birds and other things are there. They are bringing and they are leaving it in our Bomsandra Lake. Now it is full of, it's like a bird sanctuary. Now that is the benefit is being created. And next thing is, in and around the area, they are getting the groundwater at a very high level, 100 meter. Even in Vidyaranyapura, there are open wells are there. So this is how this project has benefited the surrounding people, and around 3 lakhs people are benefited by this rejuvenation activity. So some of the things which we cannot quantify is, now there are migratory birds are coming back, and there is a 4 million liter water evaporation is taking place, means that much quantum of heat sink is also happening because of these lakes. So this is the plant, because available area is only this much. Here itself plant was constructed. So then further what we did is, we reached beyond the Bengaluru places, and we have gone for the Male Mahadeshwara MM Hills. There acute water shortage was there. Water shortage there, the rain is around 900 mm only, because it was getting the retreating monsoon. So there what we did is, we have constructed the check dam. The check dam is holding the water of around 20 to 25 million liters of water it can hold back. Such a big check dam we have constructed, and thereby water is retaining in those check dam, and the animals which is coming out, and there is animal and human conflict used to take place. Now these are the core zones we have constructed, and animals are trying to stay around that region, and they are not coming out. The basic concept was to avoid human animal conflict. In order to avoid this has been created. So these are the 2 places. That entire valley is around 20 kilometer. In the 20 kilometer, first pond we constructed at 8 kilometer, and the next one is created at the 14 kilometer. So a 7 kilometer range, there is water stagnation is happening, water retaining is happening. So then further, there is a seepage water will be there in that remaining channel. There smaller animals are living, and they are drinking the water, and they are not coming out of their core zone. So this is one more lake. So 1000 meter cube water holding capacity we have constructed by excavation and other things. All these things happened with the request has come from the forest department, and we honor their request, and it has been created. Now there also water is going down in that lake, but these animals, whatever the water is available, they are making use of it, and they are staying there. So way forward, one point I would like to emphasize here is, first one is the storage of the water, which everyone is taking care and are adhering to. Second, demand creation for the treated wastewater use. Since morning we are hearing the water will be generated and it will be sold to the customers. So first and foremost, have to identify who is going to be the customer, then how the transportation will happen, then what is their use. So that is one thing. The demand to be created for the treated water. Supply has been created now. Now where is the demand? That is the one point to be addressed. Second one is upscaling of the quality from grey to green. That anyhow technology, a lot of technologies are available, then that can be treated. The fourth point, what I am trying to emphasize here is the treated water for construction purpose through some regulatory mechanism there should be there. There should be a demand from the there should be a demand from the regulatory side, that is called extended producer responsibility. Now already extended producer responsibility scheme has been introduced by government. MOEF for the plastic is there, battery is there, electronic waste is there. Similarly, construction and demolition rule also is going to come. So construction, demolition also they have to take the extended producer responsibility. In the sense I will tell you, last 22-23, MOEF has declared 2.8 million tons of extended producer responsibility has been accounted under the plastic waste management. That means 2.8 million tons of plastic will be collected back by many organizations. There are producers, there are manufacturers, and that will be treated so that much load on the environment will be avoided. Similarly, so extended producer responsibility mechanism will be going to be enforced, in that the use of the treated water, it has to be a mandatory on the side of the builder. If that is created, automatically the people will come to the doorstep and they will collect it. So that has to be addressed. Now one good thing is there is a rule has come, treated water to be let out to the lake. So So in addition to that, if this is also being made, so then I think whatever the problem is being faced will be addressed. One example we will tell you, we are doing the gold plating. By 2030, we have to have the extended producer responsibility. In the sense, the whatever the electronic waste we have generated, we have to collect and we have to give it to the authorized recycler, so that he will recollect the gold and he will give the credit to us. Only that much gold we can buy for the further electroplating. This is the extended producer mechanism which is going to come for many of the areas. Similarly, if the treated water also made a part of it, I think whatever the problem and challenges which are being faced will be addressed. These are my thoughts, and thanks for opportunity to present my case study. Thank you.